MQTT is a popular communication protocol used in IoT networks, and in this video we will see a way to implement it using Node-RED and Arduino. MQTT protocol has a publish-subscribe approach, where messages composed by at least a topic and a payload are exchanged. Here we have a simple IoT network, and regardless of its complexity, the basic topology is scalable and should be followed. We have a broker that manages communications without letting the clients to talk to each other directly and the clients itself. A client can publish messages with specific topics and payloads, and others may subscribe these topics to receive the respective data. Note that clients only receive data from subscribed topics. Now, a real IoT network. Here we have three devices, a Windows PC, a Raspberry Pi, and an Arduino Uno. As we will see, broker application is independent from clients and can be easily integrated on the same machine. This way, PC1 hosts the broker and client 1, publishes its status and subscribes the ambient temperature from client 3. The Raspberry Pi is the client 2, which subscribes the status messages from client 1 and can control a LED present in client 3. And client 3, which has the temperature sensor and the LED in its circuit, publishes the ambient temperature and subscribes the LED trigger from client 2. On the right is the connection status of the several network elements to help you following the configuration steps. If you need, pause the video here to understand the system carefully. Assuming a Node-RED server is running on PC1, insert the IP address in a browser to start with the configuration of the broker. Let's open the flow configuration and rename it with an appropriate title. I will use AED's broker, but in fact any other is a valid choice for this example. Now, drag and drop the broker node, select it, and you can see the default configuration. I will leave it as it is with no login credentials, but you can use them to increase the security of the system. Deploy the node, and you can see the broker is online. The next steps regard the client's configuration, and they only need to know the IP address and port of the broker. Usually, port 1883 is used for unencrypted communications, while 8883 is for encrypted ones. Now, let's connect client 1, that is also hosted on PC1 like the broker. This client publishes its status and subscribes the ambient temperature from client 3. So, drag and drop a subscribe node and a publish node. The incoming messages can be viewed through debug node, and for the publishing, a simple string will be sent to the publish node. As we now have both MQTT nodes, let's configure them. Open the subscribe node, and the first step is to insert the IP address and port of the broker. Since we don't have any, we must create one. Insert the IP address of the broker. As the broker and client 1 are on the same machine, the address could also be the local host. The port is already fulfilled by default and the credentials remain empty. Now we need to insert the temperature topic we want to listen and click Done. Regarding the publisher node, the principle is the same, by inserting the status topic. As the broker was already configured, it is automatically selected here. In the inject node, it is possible to define the topic also, but let's keep it simple and define the payload only. This is only the payload string, so we can write whatever you want. Click Done, and then deploy, and you can see client 1 is connected. Switching to broker tab, we can see that one client is online. Broker and client 1 are currently online, thus PC1 device is fully configured. So let's pass to client 2, which is a Raspberry Pi. As in PC1, a Node-RED server should be running on Raspberry Pi. Open a new tab and type its IP address. This client publishes the LED trigger and subscribes client 1 status. And for that, drag and drop a subscribe node and a publish node. The incoming messages can be viewed through debug node as in client 1. And for the publishing, two simple strings will be sent to the publish node, one for turning on the LED and the other for turning it off. Open the subscribe node and insert the IP address and port of the broker. Since we don't have any, we must create one. The port is already fulfilled by default and the credentials remain empty. As expected, the configuration is similar to client 1. Now insert the status PC1 topic we want to listen and click Done. Open the Publish node and insert the topic LED. The broker is selected automatically. To finish, let's configure the payloads to control the LED. These messages should be correctly interpreted by client 3. Click Deploy and you can see that client 2 is connected. Switching to Broker tab and we can see two clients online. At this point, the system only waits for client 3 to become complete. You can see the respective circuit, which is pretty straightforward, with DHT11 sensor on the left and the LED on the right. This is a quick briefing about the Arduino code. You can download it through the link in the description. As we saw, this example uses an Ethernet shield, but of course any other interface is possible, since what we really want is to take advantage of the pub/sub client library. This library allows an easy implementation of the MQTT protocol from client point of view. And now let's see some functions. This callback is an important step to format the messages in a more friendly way to use in our application, and it's called in every arriving message. Here we have the connection data and both network objects, Ethernet and MQTT. The first one regards the Ethernet shield communication. And now let's see both main functions of the Arduino. The setup function, where all this stuff is initialized, and the loop function, where first we control the runtime of the MQTT client object and monitor its state. And below we have two basic functions. The first, to control the LED based on the receiving messages under the topic LED, and these messages are published by client 2. And the second publishes the ambient temperature under the topic temperature. In this network, only client 1 subscribes this topic. And this finishes the configuration of client 3. Now we can see the connection with the broker. We can open Serial Monitor to reboot the network connection, and we can see the Arduino connecting to the MQTT broker. And from the broker side, we can see now that there are 3 clients connected. At this stage, the broker and all clients are configured and the system is complete. Now we can pass to the testing and see how this works. Client 2 subscribed the topic status PC1, which is published by client 1. When we manually send the string saying PC1 OK as payload, only client 2 receives it. We can see these messages through the debug node on the right side of client 2 interface. Here, client 3 publishes the ambient temperature every 3 seconds. Client 2 subscribes the topic temperature and receives this data within this time frame. As the previous case, we can see this information on the right side of client 2 interface through the debug node. At last, client 3 subscribed the topic LED, which enables receiving commands to control it. When client 2 publishes these commands, it's possible to see the LED turning on and off.